Hello and welcome to our introductory overview video of the week 3 content regarding foundations of inferential statistics. This is going to be a big one. It is. It is a lot of content. When I made this, I pulled material from 3 different chapters that I normally teach in an introductory stats class, and that normally is over a month of material. And in a 16-week class, that gets shrunk down to 2 weeks. And in an 8-week class, that gets shrunk down to a single week of content. So this is going to be a lot. It's a lot of things packed into here. Um, the good news is, if it can be called good news, this is kind of the peak of the hill, I think, in regards to the workload of this class. If you recall, we have the homework on Canvas that we have, but then in the second half of the semester, we switch to article reviews. So we're going to have the homework and then the article reviews. For the article reviews, for those of you who aren't as big into the mathy stuff or into Excel, article reviews are going to focus a lot more on the interpretation. They're not just going to be article reviews, they're going to be covering the statistical method we talk about too. So it's going to be some kind of homework questions tied in with an article review. But again, a lot more focused on interpretation rather than the focus being on calculation, um, which kind of goes with the goal of this class. We're training you on some of the basics right now and some basics on how to use Excel. And don't get me wrong, we're not going to necessarily leave Excel for the rest of class here. What we are going to do is, again, change our focus to be more consumers of this stuff. You'll have your analytics team run this, as opposed to you're going to run all of the statistics yourself based on content you took in an 8-week class. So I do want you to see where a lot of it's coming from so that you can understand it. But again, our goal throughout this entire class is your understanding. And even the somewhat technical equation components, we're covering at the beginning so that when it comes to interpretation at the end, we can call back to these components to understand. So it's big. It's probably the biggest week that we have. And in fact, because of that, and I think next week is going to be a little bit smaller. I'll have to check, but I think next week is going to be a little bit lighter. So what I think I'm going to do for this one with this class specifically, our semester here in fall of 2023, is put together our homework assignment. It should be already posted now. Of course, if you're seeing this, it is all already posted. If I can figure out how to work the darn Canvas. Um, but it'll be posted. I think this homework assignment you're going to have unlimited tries on. So you can try it, however long you want. And some of you have noticed I don't release the answers. The reason is so that you can retry, because if I release the answers, then you know the answers, so you can't retry it. For the number problems, I'm able to incorporate some random number generation so that there are different numbers every time you look at it. But for the multiple choice, it doesn't work that way, unfortunately. If you're ever curious about that, you can send me an email. But I'm digressing a bit. What I'm trying to say is I think we're going to give you infinite tries on this quiz, and we're going to make it due not at the end of this week, but at the end of next week. Because next week's a little bit lighter, if you're getting pushed for time in this, and the homework is a little bit longer in this one, because there are so many concepts in there, then hopefully that extra time will help you to really put your best foot forward with this assignment. But I think I can't remember if this is our last homework assignment in this format or if maybe we have one more next week. But pretty soon here, we're going to start switching over to those article reviews. And again, it's going to feel a lot less calculation focused and a lot more interpretation focused as we have mastered the basics, this week being the, again, culmination of that, and then move forward. All right, so the big purpose of this video, and I apologize for rambling on so much here, is to talk about what the goals of this are. So the foundations of inferential statistics, I really mean it. I have looked at a lot of stats textbooks, and I've taught a lot of stats classes over the last decade plus, and I've never seen content covered quite in this way. It's going to have a lot of familiar things if you've taken a stats class before. I know there's some of you in this class who have, but it's also, I think, going to um, have talk about them a little bit differently. My goal is to approach a core issue as to the logic of what we do with inferential statistics and where all of the pieces come from and what gap each of them respectively fill. That's the goal of this. So that on leaving, you might not be as familiar with the calculation components, but you're much more familiar with what is happening at a conceptual level. Um, Now, there will be some calculation stuff, and I believe your homework has maybe half a dozen or to 10 calculation problems in it. And of course, please use Excel for all of those. It'll make your life way easier. I'll show you a little hack in our Excel video as to how I get the data from Canvas to Excel, and it's very hacky, but if it works and it saves you time, then it's worth it. Um, but again, the goal is ultimately interpretation and conceptual understanding. So there's going to be a lot of slides without numbers or equations, but that's intentional, and I encourage you to pay attention to that, even if it seems kind of boring, even if I ramble a little bit, and I know I do, because that information actually is important, and it really will form the foundation in a very literal sense of everything we're going to talk about for the rest of the semester. All of it is going to draw back to our sampling distributions. All of it is going to draw back to our critical values. All of it is going to draw back to hypothesis testing and confidence intervals. Those things don't go away for the rest of the semester. In fact, I start to assume you know what they mean so that I can dive deeper into what they are for these specific cases. And that'll be the last 3 weeks, I think, is 3 different analyses with the applications of each. Um, and lean back and say, hey, remember, because the sampling distribution is this, then we know this, this, and this about our particular application this week. Um, so so pay close attention to this one. It's the most work intensive, I think, week that we're going to have in this class. And you'll have to tell me if I'm right or not. I think so. Um, but it's also, again, the most important because it really does touch on everything that we're going to do later on. I don't want to dismiss the previous week's content. And again, all those statistics, those equations are important because we need to do them. Those are the components that we use this week. But this week is kind of the key turning point. This is what we were building up to last week and is what we're going to base the rest of the content on. So pay close attention to that. And again, really challenge yourself to not glaze over. And I know it's easy. I know it's easy. And there's a lot here. So it's going to be really easy to do here. But really challenge yourself to not glaze over. Challenge yourself to push forward and really try to get what the heck is going on underneath with these Geldart statistics. I will say this stuff is what takes statistics from the realm of anywhere between just doing our descriptive stuff, which is um, useful, limited use, but still useful. You know, what happened, figuring out what happened and summarizing that information. It's a good way to summarize things that happened to hocus pocus when we make predictions about millions of people based on just a few people. It can feel like hocus pocus, and in many ways it is hocus pocus. Um, but for the logic and rationality and system that we discuss in this video, and even or I should say in this lecture set, and even in this lecture set, we're not going to go into a lot of the mathematical proofs. I'm going to reference them and reference what niche they fill and leave it to you if you're interested to go and look up some of the details. I'll say the details are certainly outside of the scope of this class. And don't feel bad if they're outside of your scope of understanding. It some of this stuff took many, many years to come about by a lot of smart people working to demonstrate this. That central limit theorem has half a dozen different proofs, and the While the original concept was posited hundreds of years ago, the modern version of the proof is only 70 years old. So it's taken a lot of smart people a long time to really wrap their heads around what the rationality, why this is going on, and why this is a mathematical proof as opposed to just making stuff up. Um, but again, we're going to skim over that in this class. That said, the fact that those proofs exist is what gives validity to our conclusions in the certain set of circumstances that we're going to talk about, and pay close attention to that too in these videos. Where does this apply and where does this not apply? Where could I use this and where could I not use this? In the homework, I try to give you a couple examples of both of those. Where is this usable and where is this not usable? And I think there's even one or two problems that discuss some potential misconceptions that someone might say about some of the things we're going to talk about, and ask you to identify why these are misconceptions. Trying to think of other things related to this. I think that's the biggest components here, is really focusing on the conceptual side in addition to the math side. I'll say the math side, while important, is largely going to change. I'll reference back to the math stuff we talk about in this. But the test statistics and the critical values are going to come from different distributions as we move forward. And the test statistics are going to become different test statistics to be put our data on those different distributions moving forward. So we're still going to reference those, but the equations aren't going to be the same. So don't feel bad if you're not memorizing the equations. I absolutely don't expect you to. And don't forget, you can use your notes and the videos. Any class material is completely fair game to use on the homework, just not anything outside of class. So any class material on the homework, please use those notes. Please lean on those videos, examples. Please lean on all of that while completing the homework assignment. Let's see. Yeah, so again, pay attention to the fundamentals, pay attention to where they apply, and pay attention again to the logic and rationality. Ultimately, with regards to the concepts of what we talk about here, the goal, especially in hypothesis testing, one of our methods of inferential statistics, is to provide convincing evidence. Our goal is to convince ourselves of something. We start with a default belief, and our default belief is that, the new program didn't work. It's kind of status quo. That wasn't really effective. Um, and then we try to provide evidence that convinces us that no, 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 it actually does. Think about trying to convince somebody who's doubtful in an argument. That's what we're doing in the hypothesis testing process, where we're trying to let the data convince us. And we have a preset level of, all right, you convinced me this much, so now I'm going to start believing you. So pay attention to that. Pay attention to that goal of being convinced by data and how we put that together, because it's a really, really important component of what we talk about with inferential statistics. All this to say, when we make decisions about populations based on samples, when we decide about a whole bunch of people we've never seen or met, or collected data on, or seen data collected on, based on just a few people we've seen or met and collected data on, that process is fraught with peril. And without very careful consideration of how to build that up logically, we leave ourselves open to presenting evidence that is very flawed. The goal of this video is to really discuss at a deep conceptual level why statistical evidence is a very reasonable and rational way to present information regarding not just the people that we've studied, but the people from potentially the whole world who are represented by the people we studied. And that's the purpose. That's the purpose of this lecture set. Again, in the future, we'll talk about specific applications, but understanding the rationality of the evidence, understanding the strengths of the evidence is important no matter which method you end up using. Because if you don't get that, all of your methods are equally flawed. Somebody's just going to come and tell you, well, hey, you collected data on 30 people. Our hospital system has over 300,000 patients we serve. Why should we make a decision regarding those 300,000 when you have only talked to barely a fraction of that? And if you can't answer that question, it doesn't matter what statistical methods I teach you in this class, they're all going to have that flaw. That's going to be an argument against all of them. This video lecture set is intended to address that argument. Why does this make sense? How do we account for that level of uncertainty? And, not to give you a spoiler, but the answer is we do account for that. We do account for the fact that we only talk to 30 people. We do take that into account. We are very careful about that and about what we do with that. And we are very careful about the types of things we can say and the types of things that we can't say. And that distinction, that technicality as it may seem as you're watching through some of that technicality comes from the amount of care that we are giving to that concern. That we want to be very careful that we are not overclaiming because we did only talk to 30 people. But that said, we do know that based on this 30 people, there are some decisions we can make. And those decisions can be very powerful. Those decisions can be very impactful. And those decisions can drive immensely beneficial practices to all 300,000 people just based on this 30. So we want to make sure we're not overclaiming, but the goal of this is to teach you why this isn't, why we shouldn't underclaim either, that this actually is powerful and rational and a good set of evidence. So I hope you enjoy it. As always, please feel free to reach out with any questions you have. And I wish you the best of luck on this week's content, Foundations of Inferential Statistics.